So today is July 20th. I don't think today's going to be super long, so there's 2 lecture slide sets, and then we're going to do this lab 3 on Nobel laureates. And if you did get a chance to read this BuzzFeed article, that's good, but it's not critical. Even though it says it's crucial, it's really not. It's about Nobel Prize winners and who comes from the United States. A lot of the prize winners are in the United States, but some of them come from the United States, and some of them actually originate from outside the United States, and that's the analysis that we're going to go through. So with that, I'm just going to jump right into the slides, and I think it works better if I share just. I'm going to stop sharing, and I'm going to share the just my Chrome window. All right, so just like every time, we're going to go to the home page. I'm going to go into week 3, wrangling and tidying data. That's where we are. And we're starting on part 5, which is working with multiple data frames. This is cool stuff, especially if you've ever worked with database stuff. All right, so this is all about multiple data frames and how to make them work. So we have a bunch of data frames, and we want to bring them together. That's what this is all about. Okay, so let's just start with some data. So we're starting with a little data set here, information on 10 women in science who changed the world. So this is from a Discover magazine article, and here are the top the 10 women in the list. So we'll learn a little bit about them a little bit later, but those are who they are.
Pretty sad. I only know the top 2.
Well, let's see. We'll get to them. I know that. Yeah, only 2. I think I only did 2 when I looked at it the first time. Anyway, so this is there's three data sets that we're going to look at, and they're all small, just so that they're tractable for the examples. So we've got this one called professions, and this is got 2. This professions data frame has 2 columns. One's name, so Ada Lovelace, Marie Curie, blah blah blah, Marie, and the other one is what was their profession. So Ada Lovelace was a mathematician, Marie Curie was a physicist, and then all these other people who, I think this one here, Katherine Johnson, was a mathematician. She was in that Hidden Figures movie. Yeah.
Rosalind Franklin was a DNA.
Oh yeah, that's right, Rosalind Franklin. Yeah, she had a lot to do with discovery of the DNA.
Was she the one that didn't get the credit though, because the other guy?
Probably.
She didn't get a Nobel Prize, I don't think.
And these ones, one of these ones had to do with, we'll get to it, but the CRISPR stuff, like really relatively recent stuff. Anyway, that's the professions data frame. There's a dates data frame, and that's got a name column, and you'll see that this may come up another time. There's a name column and then birth year, death year. So these 3 are still alive down at the bottom. And then there's the works data frame, which has a name column and then just a long string column. What are they known for? So Ada Lovelace is known for computer algorithms. Marie Curie is about radioactivity. Let's see. So where was the one that you were talking about? Oh, maybe they're not all in here. That's probably.
Yeah, calculations of orbital mechanics is the one that's Katherine Johnson.
Yeah, that was about.
And CRISPR is the last one, like you were saying.
The last one, yeah. But there was one that's missing in here that we talked about, I guess. And
Rosalind Franklin isn't.
She's not in here. Okay, so you'll notice, right? So some of the data is not in all of the tables, and that's critical for what we're going to do today. Okay, let's keep going quick. Okay, so we have those 3 inputs, and what we'd like to do is we'd like to take those 3 data sets, slap them all together, and come out with this desired output, which is it's got all of the people, right? All of the women in science, and then it's got 5 different values. One of them's the name, then there's the profession, the birth year, death year, and the known for. So that's all of the values, all of the columns from all of the other data sets, and where ones didn't exist, we still pull them in, but we just may not have a value for it. So here's Rosalind Franklin. The chemist, she didn't have a known for element, but we pulled her in anyway, and we just made it an Na. So that's what we want to get out. So this is just a little bit of a reminder.
Actually, it's DNA, not Na. That's a joke.
Good one. Just for remembering, right? So inputs, if we do names on everything, we can get a quick understanding of what the columns are, right? So each of these data frames, we've got professions, dates, and works, has a name column, and then some other column that's related to what the contents is related to. And then we look at the number of rows of each of these data frames. The first one's got 10, which is the complete set. And then the second one's only got 8, and the third one's got 9. So they're different lengths, and they got different stuff, but they all have this one name column, which is going to become critical. All right, how do we join data frames? So there's a lot of ways to join stuff together, and we're going to go through these, but they're kind of in, well, they're not really in order of importance, but the ones that you'll end up using a lot are the left join and like inner join. Those ones we'll use a lot. But anyway, we're going to have examples of all of them. But pay particular attention to those two because they're ones that we use a lot. So let's talk about joining data frames. So now there's two different data frames that we're going to start using. One of them is like this super duper tiny set of data frames because we're going to do examples of joining. So there's the X data frame, and it's basically got 2 columns. It's got a 1, 2, or 3. It's got an ID column, and it's got some random value column, and then there's Y, which has an ID column and a value of Y column. And you'll notice the ID on X is 1, 2, 3, and the ID on Y is 1, 2, 4. So they don't have the same IDs. Okay, and we'll see when we get to, yeah. So here's the illustration. So we're just going to go through these one at a time and sort of describe. And you can see there's a little visual, and I hope that's animating for you slowly. That each of the joins has a little bit of a different behavior, and we're going to try and point them out and understand them based on their name, kind of. Okay, so the first one's left join, and the left join says, I want to join X and Y, but I want to keep all of the data from X from the left side of what I'm doing. So left X is left and Y is on the right. Just that's how it's laid out. And the left one I'm going to keep everything from, and then I'm going to fill in. I'm going to take all the columns from Y, and I'm going to add them to the X, and then I'm going to fill in only where there's data. So if there is no ID 4 on X, then it just goes away because I care about the left join and pulling in the parts from Y that match. Does that make sense?
Mm-hmm.
Okay, good. Okay, so we're going to see a bunch of examples of joins kind of like this, and some of them are easier to grok than other ones. So just stop me if there's a question. But if generally what I want to do is I'm going to take the left one, which is generally it's the more complete data set, and maybe I have to figure that out. And I'm going to add more stuff to it wherever it's matching on the right. Okay, so that's my left join example, and then I can do a left join example now on the women in science example, which is a little bit bigger. So if I take professions, right? So professions was, if you remember, the name and profession, which had 10 rows in it, and I'm going to left join dates to it. So when I do a left join with the pipe, the thing that gets piped in is on the left. And so when I do the left join, professions is the left one and dates is the right one. So I'm going to take all of the rows from professions, and then wherever the name matches, on the right-hand side, I'm going to pull that data in. And where there is no match, I'm just going to give NAs. So there's some implied stuff, but I think we'll get to those slides. So that's the left join example. And so a right join is just like a left join, except the right side is the one that's kind of the master, and it's pulling all the things in from the left that match. So in this example, Y is on the right, and Y has IDs 1, 2, and 4. And when they're joined together, those IDs 1, 2, and 4 stay. And 1 and 2, which match on the left-hand side, get pulled in, and the 3 gets dropped. So the 3 doesn't exist on the right-hand side, that ID 3, and so it goes away. So you'll see, depending on these X and Y, the left join and the right join results can be very different, very, very different. And the key bit is, if it's a right join, the right-hand side is what stays, and I'm going to pull in the left-hand side. And if it's the left join, the left-hand, all those IDs stay, and I'm just going to pull in the stuff on the right side. So
if you have more than 2, it would still be the furthest most left and the furthest most right?
Oh, you only join 2 things at a time. You don't join more. And to join more, you do you join 2, and then the result of that gets joined to something, and the result of that gets joined to something.
Okay.
Okay, so that was right join. So my right join example is the same example. It's the same data frames as before. So I've got professions, and I'm going to right join to dates. And so dates is the master in this case, and I'm only going to get the IDs from dates, or the names from dates, and I'm going to pull in the professions that match. And so dates only has 8 rows, and so that's the end product only has 8 rows, and I'm just going to pull in the elements, which is profession, from professions, and match them up. And so the 2 people who are in professions and not in dates, they just get dropped because they're not in the right side. So we've done left join and right join. Now
wait, you lost me. I'm sorry.
Sure.
Hold on a second. Let me just go back here for a second.
Do I want to go back to the?
Yeah.
Yeah. So
the left join.
This is a nice. Oh, you want to go to the left join? Okay.
Yeah.
Yeah. Let's go look at left join. So you have to remember a little bit about what's in these guys. But professions has 10 rows. That's the important part. And dates has 8 rows. And so when I left join, because I'm joining, my left element in left join is professions. I'm gonna end up with the same number of rows as is in the left-hand side, which is the number of rows in professions. So I'm going to pop over to right join now. So it's the same.
Actually, I'm still lost here. So the key, how do you identify that the key is name?
That's a really good question. So that was what I was going to talk about, and I should have probably said it. R will do an initial look through those tables, and if it finds a value, a column that is the same, and only one, the column that has the same name, it'll use those as, generally we use ID. Like in database, you always use like an ID, which is either going to be an integer or like a big fat weird number. And then as long, and it's like the ID column, but in this case they use name. So basically wherever there's a name column in professions and a name column in dates, that's what it's using to join together stuff.
And then you just have one variable, dates.
Right, because of the pipe. So this expression is equivalent to left join professions comma dates because of the way pipes works. So
okay.
When you pipe it in, the first argument is always the thing that you piped in for dplyr functions.
Okay.
Yep. That's a little confusing. I mean, it could have been made a little bit more straightforward if it said left join professions comma dates, then you wouldn't have to deal with that. Anyway, okay, so
okay,
that's
then just go to the right so I could just see the difference.
Yeah, yep. So now I'm right joining. So dates is kind of the master that I'm right joining to. So it only has 8 rows. And so I'm only taking 8 rows, and I'm going to match up for each of those rows.
Okay.
What's the name, and then pull in the profession, I guess, from each of those names. Yep. All right. So that was left join, right join. And now let's talk about full join. This one's pretty straightforward. It's basically just saying I'm going to take all of the rows on the left and all of the rows on the right, and I'm gonna, wherever I find a match, I'm gonna add stuff. And if I don't find a match, I'm just gonna bring in the ones, from the original table. So 3 and 4 don't match, and and they just got brought in, and then the result is NAs because they don't know what to do with the other things, right? So ones and twos, it's a full 1 and 2 are in both X and Y, and so it brings in those data just like left and right. But now in a full, it's kind of left join and a right join at the same time. The left side gets pulled in and the right side gets pulled in.
So you could do full join professions, comma, dates, right? And then you would get.
That's this one. Yep.
That's what they all are.
I'm sorry, it's not. That's a bad. Okay, yeah, you could, but if you did, so if you did a full join professions, comma, dates, actually you'd get the same thing as this because
this piping. Okay.
Well, no, because all of the rows are in the left side, and so this is equivalent actually to a full join because all of the rows are in the left side. If there were rows missing from the left side, then they would be different than a full join. Does that make sense to you?
Yep.
All right, so that was right join, full join. Here's the full join. Okay, so this full join example is not using professions and dates, it's using dates and works. So I think the reason that this is there is because dates has 8 entries and works has 9 entries, and they're the ones that are missing are different. So dates doesn't have the last 2, and works doesn't have the number 8, and they're all brought in because is that right? I'm sorry. No. Rosalind Franklin, number 4 is not in works, but it's brought in. The key part is I've got 8 on the left and 9 on the right, and when I bring them in, I get 10 because there's 10 unique ID names in the name column. Okay, so that's full join. Now let's talk about inner join. You don't have to memorize these. We're just going to go over them, and then obviously you go back and figure out the one you want when you need it. But so inner join basically just only takes where there's a match. So only 1 and 2 match on X and on Y. And so the other ones are thrown out. So 3 and 4 just are dropped because they're not on both. So the requirement for inner join is that all IDs have to only the IDs that match on left and right are kept. So the inner join example for dates and works is it's like a Venn diagram. It's just the intersection of dates and works. So you'll end up with 7 because you're going to lose the one that was an NA for works, and then the other 2 that are NAs for birth year, death year, and so you'll only get 7. There's a lot of noise. Can you mute, please? Whoever's making the noise.
Sorry.
Yeah. Sorry. Thanks. Okay, that's inner join. Now let's talk about semi-join. Semi-join's a little weird, and I'm not sure semi-join exists everywhere, but a semi-join. I remember this. It looks just like an inner join, but it's not. A semi-join. Oh, this is embarrassing. I forgot what a semi-join is. It looks just like an inner join, but it's like an inner join with some extra information. Oh, yeah. A semi-join is an inner join, except it doesn't take in the stuff from Y. Basically, just uses the join to determine what IDs are left over, what observations are left over, but it doesn't actually pull in the right side at all. So I guess it's used to just sort of find an intersection, but you don't really care what's in the Y data frame. So I don't know what the use case is for this one. It's probably to find ID intersections and stuff. I haven't seen this one used a lot. So here's the example for semi-join. It looks just like inner join, except there is no works column because it just isn't brought in semi-join. So that's what that is. And then there's anti-join. And anti-join is it's going to keep the left-hand side observations that are not found in the right-hand side. So this is kind of left specific. So an anti-join is, it's like, I'm not sure actually what the Venn equivalent would be, but it's going to join everything from the right-hand side, and it's going to throw those away, and it's just going to keep the stuff on the left-hand side that didn't have a match. So that's what that is. So let's see what happens if I do so dates anti-join works. That says, give me all the observations in dates that are not in works. So Rosalind Franklin was not in works, and everybody else was. Rosalind Franklin was in dates and not in works, right? And everybody else was in works and in dates, and so it got dropped. Is that clear? I think it's clear.
So Rosalind Franklin did nothing, you know, at all?
She didn't, she wasn't in the works table. That's right. She had a work. What was her work? I forgot now. DNA, right?
DNA. Francis and Crick got the Nobel Prize.
Crick and Watson, right? Or what was it?
Yeah.
Okay.
Francis Crick and.
Oh, Francis Crick. Okay. Yeah.
They just forgot about her.
One like that.
Yeah, they forgot about her. Yeah.
Yeah.
Anyway, so she was in dates, but she wasn't in works. Okay. So now, so that's it. That's all of the different joins that we're going to talk about. So now we're going to answer the question was asked earlier. I want to make this data frame. This is the data frame I want to make. How would I make it? So one way to do it, there's going to be lots of ways to do this, but one way, and this is a fairly simple way. Left join, for me, it's easy to understand. And so I like using left join or inner join just because some of these other joins I gotta think harder about. So if I left join professions into dates, so professions is on the left, dates is on the right. If I left join professions and dates, I get all the rows out of professions, which happens to be all the rows, and I'm just going to pull in dates, all the dates that exist for all the observations, and then the result of that has 10 rows, and I'm going to left join that result with works. So it'll still keep 10 rows, and it'll pull in all of the observations from works, and then that's how we get this result. So very quick introduction to joins. And let's see what else. Okay, so so here's a case study, an actual real case study that the author actually uses, where there's two data frames. There's an enrollment data frame, and there's a survey data frame. So the enrollment is the official enrollment records, who enrolled, and I think it if somebody drops it, they're not in the enrollment data frame. The survey, though, is everybody who initially enrolls can take the survey, and even if they don't enroll, they can take the survey. So the student provided info missing students who never filled it out, including students who filled out but dropped the class. Yeah, so the students take the survey, and they may or may not be in the enrollment group, but we want only survey info for the enrolled students. So now we're going to use these join roles in order to figure out that what we want, the survey info for the enrolled students. Okay, so the enrollment data frame has these IDs 1, 2, 3, and their names, and the survey data frame has IDs 2, 3, 4, 5, and then names and usernames. And so this is interesting because there's an ID column in both data frames and a name column in both data frames. And when that happens, you have to be explicit about what column to use. And I think it's good practice to always be explicit about how you're joining, because then there's no room for doubt. So if I left join enrollment into survey by ID, so let's go back. So I have, if I left join enrollment into survey, so my left join has 1, 2, and 3. My survey has 2, 3, 4, 5 IDs. I'm looking at IDs here. It's a little confusing because there's also these row numbers when you print the table out, but don't look at those. Look at the ones in the ID column. ID column. So enrollments, if I left join, I'm going to get 1, 2, and 3, and then whatever matches there are on the right side. So 1 is not there, but it'll still stay there because I'm left joining. 2 is going to pull in Hermione, bake along with Hermione, and 3 Sura is going to bring in Sura bake. So let's go down and let's go back and see that happen. So 1 is Dave Friday. So he doesn't have a survey, but he ended up being enrolled. And then Hermione and Sura both were enrolled and had a survey. So those are the people who took the class, basically. One guy didn't take the survey, but he was in the class. So now, where was the survey missing? So if I can do an anti-join, which remember is the people who are in the IDs that are in enrollment and that are not in survey are going to be identified. Okay, so if we look in here, that Dave Friday is in enrollment, but he's not in survey. So you can use an anti-join to find that person. And then who dropped the class means that they do have a survey, but they're not in enrollment. So what IDs are in survey but are not in enrollment are these 2 people. So if we go back here, who are in survey, these 4, but they're not in enrollment. So Peter and Mark are in survey but not in enrollment. So that's one way to think about doing this. We're going to have to practice it to get good at it. Okay, here's another one. So grocery sales are going, I want to join some things together, right? I've got 2 data frames. I've got a purchases data frame, which is 1 row per customer per item. Okay, so every customer is going to have 1 row for every item that they have. And then there's a prices row, a data frame that just says, like, for every item, what's the price? And I want to add it all. I want to add it all up and tell me what the total amount of money spent was, which turns into the revenue for the grocery store. Okay, so I've got the purchases data frame, which has customer ID. So there's 2 customers, customer 1 and customer 2, and the item that the customer bought. So customer 1 bought bread, milk, and banana, and customer 2 bought milk and toilet paper. And then the prices for each of those items, for each of the items in the prices data frame, there's a price. So avocados are 0.5, bananas are 0.15, etc. And just with a quick glance, I can see that any items on in the purchases, bread, milk, banana, milk, toilet paper, they're all in the right-hand side. So that's good to know. Although I may have wanted to figure that out algorithmically, but so the question was, what's the total revenue, right? So the first thing I want to do is I want to pull in all of the price information for all the purchases. So one way to do that is I've got to join on, I want to join purchases and price, but I'm going to join it on item because item is the common factor between purchases and prices. I think I'm going to update this and say by item because there's an ID in there too. And naively, if you're looking at joins, a lot of the time you look at the ID column, but it's not. It's joining by item. So basically, it's saying for every time I find the item bread, I'm left joining, right? So row 1 says, oh, there's an item bread. Bring in the bread column, the price of bread for that one, and add it to the data frame. So that's that gives me all of the customers, their items, and the price of each of those items. Was there a question?
Yeah, I assume that you don't have to have a unique. So I'm assuming bread can repeat, banana can repeat.
In the purchases, yeah, like for example, there's milk in 2 cases here.
Oh, I didn't see that. Okay.
Yeah, so it'll just bring in whatever's matching. Yeah, it can happen any number of times. But now I've got the price for each of these guys, and really all I care, if I care about total revenue, I just add them all up, right? So I could just do a summarize with a sum. Total revenue is the sum of all of the prices. And that gives me the total.
You might want to do a group by
Yeah.
customer, right?
Yep. So if I want the revenue per
Oh.
customer, then exactly right. I would add a group by in there, a group by customer ID, and then I would find out the total revenue per customer.
Oh, it's not ID, it's customer ID.
Customer ID, yeah. That's the thing here, that this group, this join was actually joining on item, not on customer ID.
What's the difference between mutate and summarize?
Summarize collapses all of the values in a column into a single value. So you're if you like, this one's an easy one, right? I've got 5 guys in and I've got 1 out. So it's collapsing all of that data. In mutate, I'm calculating every observation. I'm doing a calculated new column. That makes sense?
Mm-hmm.
Yes, sure.
All right. So that was grocery sales, and that's the end of this. Oops, that's the end of this slide deck. I am going to slide right into this second one, and then we can probably take a break and go into the lab. So now we're going to go and talk more about tidying data stuff, and with in mind, keeping in mind the stuff that we have just learned. Okay, so in this one, we've got data that's organized and it's not perfect, and we want to reorganize the data. Okay, so this is the one. This is in addition to the join, right? So this is about wide and high. We'll get to it. So I've got a sample data frame where I've got my customer ID, and then I've got it. Instead of having in the previous customer purchases data frame, we had 1 row per customer per item, but in this case, I've got 1 row per customer. So all of my items are in different columns all the way to the end. So that's called like a wide data frame. And what we really want to do is we want to get back to what we had before in the purchases, which is like for every customer, for every item, I want an observation, because then I can't join on the left one. I can't join with the prices table if all my data is in a single observation, because each of those has a different value. So I need them 1 row per item per customer. So how do we do that? So that it turns out there's a way to do it, and it's called tidyr. And this tidyr package is all about what's called pivoting. Like you make pivot tables in Excel, probably. It's pivoting to go from like the wide version to the long version of data. And it does a bunch of other stuff too, but that's the one we're going to talk about. Okay, so let's talk about pivoting data. This is a funny thing from Friends, if you remember Friends from many, many years ago. That's not the pivot we're doing now. We don't care about getting couches out of the apartment. So this is pivoting. Basically, the illustration is showing going from the wide version to going to the longer version. So I'm going longer here, where there's 1 row and item per observation, to the wide version, which is just 1 observation per customer. This one's a little bit wonky, this animation, but I think it shows it anyway. It goes, you're starting it wide, and then it's going to take each of those observations from all the columns, and it's going to put each one in a row. That's the basic idea. Okay, so wider has more columns, obviously, and longer has more rows. That's how you kind of think about it, and I'm going to convert between these two. All right, let's go do that now. So if I do pivot longer, I'm going to start out with data, which is like every other tidyverse function. It's going to start out with your input data frame. Then you're going to identify the columns to pivot, because you may not want to pivot like your ID column, you're going to want to only identify like the item 1, item 2, item 3. Those were the ones that you wanted to identify. And then you need to come up with you're going to create 2 new columns. One is the new names column or variable, and the other one is the values variable. So an example should clarify that. So in the case of the customer's data frame that we had up top that had items 1, 2, and 3, I'm going to do a pivot longer so I can get it back into the form that I can use to join. So I'm going to take columns item 1 through item 3. And if you remember, I'm going to go back a couple. If you remember that this guy here, it's only these columns that I care about pivoting. Items 1 through 3 is item 1, item 2, item 3. So let's go back here. So those are the columns that I want to pivot. And then my new columns that I'm going to create is item number and item. And so you can see at the output of this, the item number column, the value in there is actually the original variable name. So there's item 1, which was that first column, item 2 was the second column, item 3 was the third column. And then for each of those, what was the value in each of those columns? So that first observation of customer 1 turns into these 3 observations. And the same with customer 2. So that's pivot longer. Okay, and so we talked a little bit about why, but yeah, generally you pivot because the next step needs it, and for joining, that's a classical example. If I want to do a left join on prices, I have to have just one price per observation, meaning I can only have one item per observation, and so I have to do this pivoting, otherwise I'm kind of stuck. Okay, so now let's talk about pivot wider. So if I have a longer data frame and I want to pivot it a lot wider, I can use pivot wider. So the purchases was the result of what I had done before. And I'm going to pipe that, which is the longer data frame, into pivot wider. And basically it's going to say, okay, well, take all of the names, assume that the item underscore NO, that's where all my new column names are coming from. And hopefully that's categorical variable, otherwise it'll fail. And then the values are just going to take the values out of the item variable, out of the item column, and then stick them into the ones under each of the item numbers. So that's how you pivot wider. Okay, so now here's an interesting one. We're going to run through this example of approval ratings from 538, which is a website that's got a bunch of political stuff. You can look at this online if you go to the reference and see it. They got one for Biden too. I think they're fairly nonpartisan, and it's an aggregation of a bunch of ratings surveys. And I think it was updated every day, but it's looking at lots and lots of different sources of data and doing an aggregate. And so, well, we'll get into this. So the data here is approval and disapproval. So that the input data, the data frame is called Trump, and there's a subgroup, which is voters or adults. There's only 2 categories in this categorical variable, and then there's a date. And then there's this approval percent and disapproval percentage. But the data that you want to create is this rating thing. So you have approval and disapproval, but you don't have a rating. And so you've got to do that conversion. And then you want to separate it into adults and voters. And adults are like all adults, and voters are like likely voters. And they're different. And then you want to plot this is a time series graph. So every day is going to have an observation on the x-axis. Okay, so how do we do this? Well, okay, we just talked a little bit about this. If I just took this data frame and I wanted to turn it into a plot, I have the date variable, I've got the subgroup variable, but then I've got approval, disapproval thing, and I don't know, I'm not sure what to do with it. I don't have this rating value, and I don't have, and I can't color it by rating type because I don't have a rating type variable. And so I do have the subgroup and the date. So we want to convert that data frame to one that is more amenable to this plotting of the goal that we got. Okay.
Rating value you're given.
Well, no, it's not the rating value. We're giving two rating values, an approval rating value and a disapproval rating value. And we need to convert that into a single rating because they're plotted on the same axis.
Oh.
So let's go there. So, yeah, here, rating. They're separated, but they have the same column that are being used for the graph.
Okay, I guess I'm missing the complication there.
We'll get there. Okay, so the first thing is I've got this approval and disapproval, and I because I want to calculate a rating value, I need to do a pivot longer so that I get all of those values into a single column. Okay, so I'm gonna convert this approval disapproval into a rating type and a rating value. And I need rating type and I need rating value for the color coding. I need rating type and the rating value. I'm going to have to do a little bit of math on, but the rating value is I need to convert that into the rating score that I'm going to plot. That I'm going to end up plotting. So the first thing I need to do is I need to do this pivot longer to get the data in the right format. And then the next thing I need to do is actually, I don't have to do, I was going to do math. I don't have to do math. All I had to do was I had to take those two values and stick them into the same column because the rating values don't, I thought you had to invert one, but you don't have to invert one. So really it's just moving the data around so that it's easy to plot. Because in order to do this plot, I have to have these variables in the same column, this rating value. So once I did that pivot, now X is date, so X is still date. The Y is the rating value though, and the rating value is just the collapsing of the disapproval rate and the approval rate into a single variable. I didn't have to do math on that. And then the color is this rating type. Okay, the approval or disapproval, I can color it and I can group it so that when I send it to geom_line, it treats it as two separate groups. That's what the group is for. And then I facet it by subgroup. So this is an example of
what was group again?
Grouping is to separate it so that geom_line knows that it's two separate things that it's plotting. It's not going to plot this as one single line. So
Okay.
yeah, for the geom_line. So that's just an example of why I might want to do a pivot just to support some kind of plot that I want to make. And then there's a bunch of stuff like changing colors and adding labels and stuff. And then once I do that, I have all of the stuff that I wanted. So I just turn that rating_value into rating and all that stuff. And that's the end code that does it. So this is basically just an example of using pivoting in order to support the downstream needs of the data processing. And then there's the last part is this changing the theme and moving the legend down to the bottom. Okay, so that's the second data set. So the second slide set was all about pivot longer, pivot wider, and the first slide set was all about this joining. And now why don't we take a break now and come back and we'll do this Nobel laureates lab. And we can just sort of do it all together. You should have all of those in your GitHub, so that shouldn't be a problem. So why don't you guys want to come back at 8 o'clock? Or
Yeah, sounds good.
okay. All right, let's come back at 8, so you get 11-minute break. fire up my RStudio. Lab 3. Oh, I already did it. I'm gonna do it again from scratch. Ah, man. 3. So I'll take come to my case lab 3. Spin up and print it. Pete, did you get access to the other? Could you bring in the other labs so that you don't get kicked out? Okay. Anyway, okay. All right. So here we go. Well, it's 8 o'clock. You guys want to start? Already back. Hello. Can you hear me now? Oh, no. Hello, anybody there?
Yeah, I'm here.
Yeah. All right, good. Okay. So let's start. So does everyone have the lab? Let me shove it into the chat. There's the lab, and you can go to GitHub and get your lab Git repo and put it into the RStudio Cloud and fire it up. I'm just going to do that, just the basic blocking and tackling of getting through, and then we'll go back and read the lab. So I'm going to open my RMD file. It will ask me if I want to install packages. I'll say yes. I'm going to preview in the preview pane. And now I'm going to go over and read a little bit about the lab. So in January 2017, BuzzFeed published an article on why Nobel laureates show immigration is so important for American science. You can read the article, maybe you have. In the article, they show while most living Nobel laureates in sciences are based in the US, many of them were born in other countries. And this is one reason why scientific leaders see immigration is vital for progress. So in this lab, we are going to try and recreate some of those visualizations. And when we do that, we're going to have to wrangle a little bit of data. Okay, so this is the article that you can go and read if you haven't. And now we pop over to the getting started bit. So the getting started bit is just like every other one. And so I'm going to go over and see if, oh, it's still loading. Taking a long time to load. Well, while we're waiting, actually, Pete, you said that you ran into some limit, or you're going to run into a limit on RStudio Cloud. I'm afraid to change this. Did you get an email that told you that?
Yeah.
Okay. So I guess if somebody gets an email that says you're going to run into a limit, there's a couple of things you can do. One of them is you can load up your local RStudio and not use cloud. Then you don't have any limits. Or you could actually just sign up with another email if you run out of, credits with one email. You may not run out of credits, so you can check. At the end, we'll talk about checking. So let's just do the insert your name and knit once. Make that thing feed. Can you mute, please, Jackie?
Those are great sound effects.
I'm gonna knit just to. I think I may have to. Yeah, to load this one more thing. So let me know when everybody's up to the knitted part.
I did all that, but I immediately ran into problems.
What happened?
I just can't remember any of the syntax for like nrow, and so actually I have two questions. So when you knit the file,
Yeah.
then I copied and pasted the library code and the Nobel, the read code into the console. Do I need to do that, or is it executed in the knit?
So when you knit, all of it runs in its own environment, but you were able to knit correct and put in.
Yeah.
Okay, so that's good. I think the copy and pasting, you're going to want to put it in your console if you're going to want to look at any of the data or do any like exploratory stuff. The easiest thing to do is to click on the little green arrow instead of copying and pasting. That'll run your chunk and that shouldn't have any problems. So if you
I just wasn't sure because I've done it a bunch of different ways, but I thought of that too.
We'll just overwrite it. Yeah. This little message that I get, I got to do. Oh, message equals false. Oh, but so if you execute lines 11 and 15, then at least you'll have the the data frame in the console and in the environment.
Mhm.
Are you able to do that now? If you just click on
Yeah.
it? Okay. Yeah, copying and pasting can be a little bit of a hassle sometimes. All right, so we did the warm up. We updated our YAML, putting our name in. We knitted. You don't have to commit and push until there's something interesting to commit and push. You can
Yeah,
use
I
recipe.
got things not working again.
Pardon me?
I don't know why I can't remember how to do this stuff.
What are you trying to do? Did you run ahead?
Yeah, I'm just trying to do exercise 1.
Oh, okay. So you're able to load your library and you're able to read in your data. So that's good. The data dictionary is all here. That is the high level of all of the stuff, all of the columns in your data set. There's this stuff about country original, city original. I don't think it even matters. I'm not sure why they even told us, but sometimes country names change over the time frame of the data frame of the data. And so the country may have been Yugoslavia and it might have been changed to Bosnia. All right, let's go to exercise 1. All right, so this is where you are, I guess. How many observations and how many variables are in the data set? Okay, well, there's lots of ways to do that. If you've run the first 2 chunks, then you know that the Nobel data set is in your environment, but you can test it by going over to the environment tab on the right, and it says Nobel right there, and it actually tells you how many observations and variables there are. So you don't actually have to write any code at all to do that one.
But they say they want you to do it with inline code, which is the part that I got stuck on.
Oh, I'm sorry, I didn't read that. How many use inline code to answer the question? Oh, okay. Yeah, I mean,
I was trying to do the quote that's below the tilde, right? It's supposed to be inline code.
Yeah,
It didn't
so,
work again.
yeah, you say the backtick is on the top left of your keyboard. And you say R because you're going to execute R.
Oh, I forgot the R.
Yeah, and then you say nrow Nobel. And the best way to do this isn't to try and memorize it, but to have, you might want to go back to another lab that did it, or maybe even compile your own little cheat sheet or find a cheat sheet that's got it. But yeah, memorizing it, you'll eventually memorize it if you use it enough, but it's very painful if you don't know if it's n rows or n row, and then you get a bunch of errors.
So you can't just execute that?
Sure. Oh, can I execute this? Gosh, I don't think I can, no, because it's not in a chunk. It gets evaluated as part of the R Markdown evaluation. Yeah.
Yeah, it didn't work.
Well, let me just finish my bit and then we'll come back. Let me see, I'm going to knit quickly to see if it worked. Oopsie, I got a syntax error because I put my tick in the wrong place. Okay, so that worked for me. Do you want to show what you got or describe what you're doing?
Sure. What's it called? What's the data set called?
Nobel, N-O-B-E-L.
Okay, so how come it says read in data / Nobel?
That's the source data is in a file, and the file is in the data directory. So if you go to files, click on files here on the right side, you see there's a data directory. If I click on data, there's a CSV file in there, and that's the actual source file. And it's unfortunate that they're named similarly, but Nobel is the data frame that read CSV uses. It's reading from that Nobel.csv in the data directory to populate the data frame called Nobel.
Okay. I wrote data / Nobel because that's what it says, read CSV. So I didn't know why it was data, because
Yeah.
you're going to that directory. Gotcha. Okay.
Yep. Back to review. So did that fix your problem?
Yes.
Cool. All right, so is everyone's probably done with exercise 1? Raise your hand if you're not, or say something. Let's go to exercise 2. Create a new data frame called Nobel_living. I'm going to copy it right now. It filters for laureates for whom country is available, laureates who are people as opposed to organizations. That means their gender is not org, and laureates who are still alive, meaning their died date is not available. So I'm going to do this in pieces because I'm not going to remember everything. So I'm going to say, okay, exercise 2. So first I'm going to say create Nobel living data frame. Then I'm going to go and make my backticks. I'm going to say R and then some meaningful. What I'm going to say, this is the make dash Nobel. Remember, no spaces in your name, in your chunk name, otherwise you will get errors that are very hard to debug. I'm going to say Nobel living is, I'm going to assign whatever my expression is to Nobel living, and I'm going to pipe Nobel, oopsie, into something. Okay, well, what am I going to do here?
Hold on a second.
Yeah.
It's just hard to do it at the same, unless we're doing exactly what you do.
Oh. Okay, I can wait.
Can we try it, or you'd
Yeah,
rather?
try. Yeah, I'm sorry. I was just sort of talking along with it, but yeah, you can just try it. Yeah.
Yeah, see, I forgot the syntax again.
So you're going to want to do a filter on 3 different things.
So the reassignment of Nobel to Nobel living is a greater than and then a dash.
Less than and a dash. Yep.
Less than and then a dash.
Like a little arrow. It's a little arrow going left. Which is super annoying. It should just be the equals. And in fact, equals works sometimes. I don't remember the rules actually. Sometimes it doesn't work.
And pipe is percent and then greater than percent.
Yep. The space too between your variable and your operator. At the end. Oh, confirm that there's 228 observations.
So country is available, so that's country is not NA. Is that what you want to do?
Yep. You have to use the not is NA operator. Yep.
But you didn't use the exclamation point there.
Yeah, exclamation point is not. Yep.
Yeah, I can't really read what you did.
I can make it smaller. Hold on.
Filter is NA country.
Does that help a little bit?
Okay. Is dot NA country.
Yeah. We should get 228. How are you doing?
Slow, but if everybody else has it, I can just.
No, keep going, keep going, keep going. Did you get the is NA in country one?
Yeah, I'm not really doing good. I'm just kind of copying what you're doing and not really thinking about it.
Okay.
You know,
Well,
it's kind of hard to think and listen and look and.
well, okay. Well, maybe we can do it differently. We can just sort of.
And maybe we should just do it as a lab, like we'll just do it and then we just ask you questions.
Yeah. Okay. I mean, and so you want to just stay online. And
Yeah, the thing is though, I kind of wouldn't have gotten this, I don't think.
well, do exercise 3, and if you don't get it, we can talk about it. Do you want to do that,
Yeah.
or do you? So I won't do it. But I'm here if you want to talk about it, I guess.
Yeah.
That works for me.
I'm still on 2 though.
Okay, well, I'll hide number. I'm gonna hide 2 then.
Well, don't hide it. I'm copying it. No.
You said you didn't want. Okay.
All right.
Died date is NA.
Yeah, they pretty much tell you that you should use that. Otherwise, you'd have to figure that out.
So there's no piping here. This is all just one big filter.
Well, you're piping Nobel into filter, yeah, but that's all.
But this filter is just one big filter. So I got closed parentheses at the end.
Yeah, you could do it in 3 different filter operations, but I just did it in 1.
Yeah, I got an error for exclamation point is dot NA.
Mhm.
Unexpected exclamation point. So what'd you do differently?
Show.
Sure. Can you see anything now?
No, oh yeah, here it comes. Yep. I don't know what that's all about. Oh, so you piped Nobel and you put Nobel as the first argument to filter.
Oh.
Sure.
That's a good one.
Oh, so on line 30, you have to use the is.na operator. You can't just say equals, and you made it into an assignment too. So, well, that doesn't look like that's what it's complaining. Oh, you have a space between your bang and your equals on 29. That's what it's complaining about.
Let's see what this does.
Sure.
What if I did that?
We detected a named input. So usually means that you've used equal instead of equal, and that's what you did. Yeah.
Do you think that would work, or?
Try equal and see what it does.
Yeah, that's definitely the problem.
Character string is not in a standard unambiguous format. It doesn't know that you're trying to test for NAs. Yeah, it's a very confusing error.
So
You
it should be died date.
You got to use the is.na operator. Well, you see on 28 how it's done? Yeah. Yep. So there's only one issue there. You've got a floating quote at the end. That should work.
Oh, got something.
So the one thing is, so it did the assignment and everything, but you didn't, you want to validate it somehow. So, I mean, the simple way to do it is to just print out the,
Or-
View
you can
it,
glimpse it, or you could just type the name and it'll print out the top view and tell you how many rows and columns there are. Or glimpse works too. Yeah.
or you could view it.
Well, not if you only knit it though. Yeah.
Oh,
you-
okay. Yeah, I ran mine in the thing.
Yeah, if you run it. Yeah. You want Nobel living though, honey.
You talking to
Yeah, I
me?
got you on that. Okay.
Yep. So 228. That's what you should get. Yep.
Okay. Cool.
So
We're
how-
not checking anything in, so just go to the next one, right?
Yeah, so let's talk about number 3. Let's see. Most living Nobel laureates were based in the U.S. when they won their
Well, this
prize.
is the knit, commit, and push, but you're saying you can't do that.
Oh, yeah, sure. Yeah, I'm sorry. I'm skipping.
I thought you said you can't do that for labs.
No, you can't for application exercises.
Oh, gotcha. So I'll just do that quick.
Sure. Yeah. If you've got your own repo, then yeah, you can always do that. Commit. You might have to log in again. Try pushing quick. Oops. Oh, good. Cool.
Okay.
So let's see. Before exercise 3, there's some stuff. We'll create a new variable using mutate. And then limit the analysis to 4 categories. So these are basically copy and pastes that you need to do for exercise 3.
Okay. So first argument in the if-else function we're using to write this statement is the condition we're testing for. If else. Okay. If else country equal USA, comma. Why is there a second USA?
So
Oh, that means write it as USA, else write it as other.
exactly, yeah. It's just like Excel.
Cool. Okay, I'll follow that. What's in?
Where are you? Oh,
And why do you have a C?
I'm sorry. What? Where are you?
The very next thing.
Oh, yeah. Okay. So yeah, I'll explain this a little bit. So so in is an operator that we saw last time that says when you're doing a filter, the if the value of category in an observation is in this this C thing is a character vector, so it's basically a list of strings. It's a list of names. So if it's in that list, then it would include it in the filter, basically. Does that make sense, or was that?
Yeah, it makes sense.
Okay.
Yeah. Okay. What does that mean, define this data frame? I mean, we already created it.
It just says yeah, the task was to do it because it wasn't explicitly in exercise 3 said, didn't say to do it, just do it, yeah.
Faceted bar plot visualizing the relationship between the category of prize.
What? We're on to the next one.
That's
If
exercise
you
3.
created that Nobel Living Science, did everybody do that?
Yeah. Did you do that, Pete? The Nobel Living Science? Did you
Yeah,
create-
yeah. I just
Okay.
I had to go out of the room a second.
Oh, yeah. So we're just doing exercise 3, yeah.
Okay.
Winners in the US and one from other. Okay. All right, let's see if I can do this.
Start slow and small. Like just make a bar chart and then you can facet it afterwards, for example.
Okay. So this is living in the US or born in the US? I forgot. Living in the US.
Yeah, and then there's an origin country.
Okay. So we start with the one we created or something.
I'm sorry, what? Yeah, you got to create it. Yeah.
We start with the one that we made in the previous one.
Nobel Living Science, yeah.
Oh, yes, yeah.
I don't remember what comes next. So after you hit the plus, Then do you go right into GM?
Mapping equals, oh, so your aesthetic mapping, you gotta be a little careful about. See,
GM.
yeah, that's
There,
correct.
you want to look? Can you see mine?
Yeah. Your
Is that right?
AES. Well, the
So
AES.
I just want to do one plot of all the countries just to see if I got it right, because she said start small.
Yeah, totally. It's right, except for your AES is incorrect. So the AES is mapping X. For a bar chart, it's just X to a variable.
Well, okay, so what was the category? I forgot. It was country, right? So just
Country underscore US. Well, no, you want.
I thought it was just country because I have two different things in country, either USA or other
Right.
in
That's the
country. Right?
country underscore US is the one you want. Yeah, because it's only got two values. It's got
What do you mean country underscore US? I thought this code here just created another column called country.
underscore US. That's the
Oh,
mutate.
underscore US. Sorry,
Yeah.
I didn't see
Yeah.
it. Got it. Probably got to be this way, right? Hey, but they want it horizontal, huh?
Yeah, and you want to say X equals or Y equals. It gave it away, but it was interpreting because you didn't tell it which aesthetic it was interpreting as X.
That's how you change to be horizontal.
Yeah, yeah. So if you go back up to the graph,
Okay.
finish, yeah.
So that's in this right after here.
No, but so the country US, generally you make your aesthetics like something equals to it, like X
Oh.
equals country US.
So this would be like Y equals.
Yeah, exactly. Yeah, try that.
And then I should put in like titles. I forgot how to do that.
Labs or something, LAB.
Yeah, labs. Yeah.
Before GM bar.
After.
After.
Yep.
So I do a plus.
Yep. And then labs, and then you can open a parenthesis, and then title and all the other crap, X and stuff.
Double quotes or single quotes?
I use double, but single out of work, I think, in this case.
All right, mine's backwards.
Yep.
I can't get the other.
What are you trying to do now?
The axes labels.
Yeah, X and Y.
X equals.
Mm-hmm. And whatever the axis string, x-axis string you want. So, yeah, exactly. Yeah, that's the country where the award was given. That's what that is. Yeah. Yep. So the last thing you want to do is facet that by
Okay, got it. So I just do another plus.
Yep. gotta use a little tilde.
And do the name of the database,
No, the
the variable.
yeah,
What was it again? Country, US or country?
category, actually. You're faceting by
Oh,
what
the
kind of
sign
Nobel
by
Prize.
the-
it is.
Yeah, hold on a second. How do I know that? Country of origin, original city, blah, 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 blah.
It's up higher. Okay, steps up. Fit down.
Mhm.
All right, knit that and see what happens. Sweet.
It's pretty good, right?
How are you doing, Pete?
I think I got it except for the horizontal part. I was trying to look that up.
Yeah.
Vertical or
He gave
horizontal.
us a hint when you walked away to deal with the dogs.
Oh, that's it.
He said it had to do with X and Y assignment.
Oh, you put it in Y instead of X?
Yeah.
Yep, that did it.
Cool. So how do you interpret the graph?
So generally, everybody was residing in the, well, these are just US Nobel laureates, right?
Yep. I think that the takeaway is there's lots of them, especially in
Oh,
economics.
yeah, there's more than other countries. Gotcha. Okay, yeah, that's a good takeaway. Certainly in economics.
Yeah, exactly. All right.
But there's a significant amount that are not from the US too,
That's true too. But
right?
the sum of all other countries is in other, right? So for all other countries, it's
Yeah,
less than one country. You know, but you're
Yeah,
right.
that's
Something's
true.
really dominating. Yeah.
but these are all Nobel Prize winners or just
In
the
these
ones
four areas.
from just the ones from US?
No, it's not looking at country of origin at all here. It's just looking at the country where it was awarded.
Okay.
Now we're going to go and do that extra bit. So that was exercise 3. Now we're going to go to exercise 4.
I think that, oh, I did it in the wrong place then.
That's okay. Yeah, so yeah, that's fine. Your 4 is just.
Yeah, hold on. Can I fix that before you go on?
Yeah.
Hey, Zoe.
Oh, I forgot about the class. Can I hang out with Keely tonight?
I guess so.
Look at my cute outfit. I need to smell it.
Okay, gotcha. So let me just go back here. Oh, should we commit?
Sure, if you want to. I'm not gonna, because I'm working in your, I actually cloned your repository, so I'm not gonna commit.
Didn't ask me for my password this time.
Maybe I remembered it.
Sometimes it doesn't if you committed within the last,
If you
No.
do too close together or something.
recently, yeah.
Yeah, remembers it, yeah. All right, so exercise 4 is create a new variable called born country US. It has the value of USA if the laureate is born in the US and otherwise.
All right, so I can do this, I think. Can we try it now?
Yep.
Okay.
And I would just add it to the Nobel living, yeah.
Mutate.
Rename.
Foreign
Oops. Where are we on? 5, right? Or 4?
4. Yeah, you just gotta find the variable name for foreign. Let's see. Oh, born country, that's it.
If else thing.
Oh. Bloop. Oopsie, I put it in the wrong place. Shit. I want just the Nobel Living Science. I don't want.
You don't want to use the code or just for, they don't show an example with US in this little thing here.
Well, you have it in another in that example that you copied in the markdown. It's the same.
Right, but there's born country and born country code, I guess is what I'm saying.
Oh.
So I'm not sure how US is written out as United States or US.
Well, I don't know. I guess you have to look.
I guess if what was the other one?
Oh yeah, born country code. I mean, if you view it, you can see very quickly that born country is USA and born country code is US. So you just pick the one that you want, but either of them works. You might want to do that with the Nobel Living Sciences data. Leviticus, how many winners born in the US?
Foreign country code.
He said no. It's born country.
Oh,
Sorry, what?
not code.
He had the same question I had.
Oh,
Foreign country. Oh boy.
Oops.
Oh, born country. Oh, okay, because code is a shortened version.
yeah, this is US.
Country.
Winners are born in the US.
USA. USA. Other.
How many were born in the US? Okay.
So we want to create a new variable and put it in a new data frame. Apparently. Correct.
No, just put it into the Nobel Living Science data frame because you're
Put it
gonna
into the same one.
Yeah, the last one that you monkeyed with, which was Nobel Living Science.
Right. Okay.
So how do I do that? Count.
Easiest way
Let's
is
you
just
count the unique variables of one or more. So it just do the
yeah.
parentheses greater than count and then
Guess you
right.
could do that. I just filtered out the USA one and printed it, which gave me the number. But you can do it. Let's do it that way, and we'll see where you get. If I go,
So that would be
may have to group by though.
I thought it would count how many just say USA.
Well, you have
No?
to tell it somehow to count just USA.
I thought that's what this count did if you had X comma Y. No.
God, maybe.
How many winners are born in the USA?
Yeah, I think the way I did it was to group by and then to shove it into count, and that gives it to you.
Okay.
Well, it says to choose count.
Where?
So
Oh, in the sidebar.
exercise 6.
Well, we're in 4 now.
I know. count function. I mean, I think it's the same kind of thing.
Group by.
Yeah, in 6 you're gonna do, you have to do a group by 2, I think.
Okay.
Wait,
So you
what?
just can't count, why can't I just count country USA equals USA?
You could filter out that and then pipe that to count.
I can't just count for the value of USA in a column?
In the count guy, I don't think so. Maybe. Oh no, yeah, you're right. You're right. You can do that. I just had forgotten about it. So you could say Nobel living count count born country USA, I guess. And it'll tell you, would do the group by for you. Yeah, I forgot about that.
Like this?
Well, you're piping it. So the Nobel living science you don't need. You can either eliminate the pipe and do that. Oh, no, you don't do the equal sign because it's counting by that variable, and so it'll give you both.
So don't pipe.
Excuse me?
Don't pipe, you said.
If you, not, yeah, that one, right? But get rid of that equals at the back because you're not counting, you're not filtering here. You're
Well,
gonna
how do I
count by-
find the syntax for that?
It's just the variable name. Get rid of USA. It's just counting by that variable. It's shorthand to group by that variable and then do count. So if you've got to delete the USA.
Yeah, but born country USA is going to have two values, USA or
Right.
other. I only
Yeah.
want to count the USAs.
Well, then you need to post-process the output of that by just getting the one that's called USA, but the functionality of count of the data frame and a column is equivalent to group by, and then piping that into a count, and it's going to count all of the values in that variable.
I just did both of them.
Yeah, that doesn't really help. That's not really, that doesn't do anything.
Oh,
I mean, that's just going to count my number of, every value, every row is going to have a value, either USA or other. So count isn't going to really do anything.
Well, try it. Just get rid of USA there in the comma and run it and see what you get.
Oh, okay. So it does show you it. Okay. Well, that's kind of cool. So it lists a what do you call that?
The frequency table.
Frequency table. Okay. That's what they say to do in 6. Yeah.
Okay.
But we're still on 4, right?
Yep, we did 4. So how many do you get? How many winners are born in the US? What'd you get for that?
105.
Yeah.
Oh, everyone got 100. Okay, cool. So we're done with 4 now. 4. Okay, let's go into 5. Add a second variable.
Hold it.
Okay.
Just knitting 1 second. Okay. Yeah, I got a big old error now.
See, what happened?
Yeah, I think I don't know. I don't know what.
It's in the mutate. It doesn't like it.
It ran it before when I just ran the block.
Oh, it said so.
Oh.
If you read the error, it says duplicate chunk label birth country.
Yeah, I did the same
Used
thing.
for the chunk. Blah blah blah. So
Yeah, that gets me a lot.
Chunk names, yeah.
Oh. Still have a problem.
Can I have any of this or no?
Yeah, I guess so. You want some real food?
Sure.
Yeah.
All right, what is that color, right? Born.
Are we working on 4?
5.
Okay, sorry. So they want us to have it below.
Here we go.
Can you put a number? How come I got a space here and it ran it?
It's something bad's gonna happen. I would get rid of that space.
A facet for
Okay.
each category. Oh, we're adding another facet. Is that correct?
No, you're gonna add more details to each of the bar plots. You're gonna do the bar plot by another categorical variable, the country of origin, or USA or not USA, basically.
Yeah, that's what I tried to do. I tried to do an X and a Y, but you can't with the bar plot, right?
Yeah, I can give you a hint if you want. If you go back to lecture number session 2 part 4 talks about bar plots, and then that'll give you the hint that you need. Do you want me to send you the slides, the link?
Session 2, visualization.
Yeah, the visualization stuff.
Part 4. Visualization. Oh, fill by. Oops.
Yeah.
You put that before facet wrap?
It's part of
AES?
yes.
Yeah.
Yes.
Huh. It's not coming up as a.
No, it's called fill. Yeah, fill equals. No, it's just fill. Fill equals, and then a variable name.
Did it do it? Oh, yeah, it did it finally.
What do I do? I'm stuck.
Fill equals born underscore country underscore US, which is that new variable that you created, whether or not they were born in US or not.
Can
Well,
I take the big card?
so what's the difference between Y and fill? Yeah, you could take it, Zoe.
Y is what you did before. So Y is the value, the total value of the count of the country where the award was given. And the fill is the country is breaking down that total count by the number where the country of origin was the US versus the country of origin was somewhere else.
Right.
Knit that and then you'll look at the graph and you can get a better idea. Yeah.
Yeah. Oh, that's pretty cool.
That's pretty cool.
So then now you can see of all of the people who were actually awarded a Nobel in the US, how many of them weren't born in the US? And some vice versa.
Yeah.
Yeah, some.
Number 6 is what we're running. We only have a couple minutes left. Filter for 200. Actually, I don't know if this cuts us off. You want to go on to 6?
Sure. Single pipeline filter for laureates who won their prize in the US but were born outside the US, and then create a frequency table with the count function.
In 5 minutes, right?
Yeah. So.
And then they arrange it. Whoa.
Yeah, well, the first thing is the filter part. That's the most important part. Everything else will happen after. Will come pretty basically.
All right, I think I'm gonna do this on my own time.
All right.
Yeah, you can come down here and help me, honey.
All right, I'm gonna do it first and then I'll come help you. All right, thanks everybody. That was really
All right.
Bye-bye.
Bye.
You did great.
Country US equals.
Yeah. Mm-hmm.
That's it. Just filter, what am I
You're
doing?
filtering where country US was awarded in the USA, right? So that equals USA, right? Equals, two equals. You know, you need to make USA a quoted string. And so another comma. Born country underscore US
Goes other.
or not equal to USA. Yep, either way works. Then you want to pipe that into account.
I have to pipe.
You don't have to pipe it in, you have to pipe it out. So that filter's fine, And then you're gonna pipe that into count, and you're counting. Yeah, get rid of that. Yep, you're right. But you're counting by born country. You're counting each, like how many from each country. Yeah. But get rid of this guy because you're piping it. Yeah, so run that big boy. It ought to work for you. The only thing is it's not sorted, so you need to sort the output.
Okay, so. Comma?
Before the paren though, yeah. Because you just say sort equals true. Oh, you want to pipe it into a range, then you'd pipe it into a range. Sorry, either way works. Yeah, so close that and then pipe it into a range. Yeah, range, and then
by group equals.
I think it's a single, after you do the count, a range, try
Foreign
just
country USA.
just try a range. I don't think you need to do anything. Because there's only one thing it can
Let's just
arrange
see
by.
what that is.
It might be n, I can't remember how the syntax of that actually. No, born country, it's n, n, not
What's
born
wrong with
country.
that?
Oh, because you arranged it in alphabetical order, you want it in the number, in the decreasing number of n.
Oh,
So it's n, yeah, you want n. But you're gonna get it in increasing n, but it's okay, try to do it now and make sure it works. Yeah, so it starts small, so now you have to say DESC and in descending order, DESC. And then parentheses, and yeah. And then on the other side of n. Yeah, try that, see if that works. Yeah, that's right.
pretty good, huh?
So that's pretty cool. Okay, knit it. Make sure your output looks yummy. Oh, there's a fucking fly. The one thing I think